All right, this next one's kind of a bear. It's another one that involves only even powers of trig functions, right? We have sine to the fourth, we have cosine squared. So we can't just break one off and, and do substitution. So now the tip we had before was that if we have even powers, we should try using either double angle or half angle substitutions for it. Now, I actually did this two different ways, and I'm trying. I think I'll just do that. What I found to be the easier way. I did the hard way first, and then realized, oh, I could have done this probably a little easier. Um, so I'll show you the easier way that I found. But I just want to just make a point that I got the same answer both ways, but um, it's yeah. Sometimes you don't choose the easiest solution right off the bat. And there are multiple ways to get it done, right? So what I'm going to do on this one now, and the other one I used the kind of the half angle formula or the power reducing formula. In this one, what I'm going to do is I'm going to combine, so I can combine it's basically sine squared times sine squared, right? The sine to the fourth. So what I'm going to do is I'm going to combine one of the sine squareds of x and cosine squared of x, right? Now I'm going to go ahead and I'm going to have a sine squared of x again, dx. Now the reason I'm doing that is because I have that identity. Now it's up a ways, but I have the identity that sine of theta cosine theta equals 1/2 sine of 2 theta. So I can take a sine times a cosine and reduce it down to just a sine, okay? So what I have here is essentially, this is sine x cosine x squared, right? So I can actually make this into 1/2 sine of 2x, that whole thing squared. Okay? All right. And then over here on the sine squared, what I'm going to do is I'm going to make this into 1/2 1 minus cosine of 2x dx. Okay, so this is the same. This is equivalent to what I had before. I've just done a couple substitutions. Okay, now I have everything in terms of 2x. All right, so let's see what we can do with this. Well, all right, I'm gonna have a half squared, and then I'm gonna have times a half, right? So that's 1/4 times a half is 1/8. So I'm gonna pull a 1/8 out of there. So I get rid of the constants. All right, and then I'm gonna have sine squared of 2x times 1 minus cosine of 2x dx. And I'm going to distribute that sine squared of x. So I got 1/8 integral of sine squared of 2x. Okay, and then minus sine squared of 2x cosine of 2x, and that whole thing dx. Okay, so you can say I can break it into two integrals, and now I can see here I can easily use substitution, because if I say w is equal to sine of 2x, then dw would be 2 cosine 2x. Okay, so I can apply substitution to that portion of it, and then over here, the sine squared, I can reduce the power again on that one. All right, so let's break this thing up. So I'm going to have 1/8 integral of, and I'm going to replace now this sine squared of 2x with 1/2 1 minus cosine of 4x, right? Dx. And then minus, to watch myself here. Okay, I'm going to distribute the 1/8, so I still have this 1/8 here. This integral of Now, and I'm going to do substitution, all right? Like I just said, I'm going to say w is equal to sine of 2x. So dw is equal to 2 cosine of 2x dx. Now, I don't have 2 cosine. I have 1, so I'm going to divide both sides by 2. So I get 1/2 dw is equal to cosine of 2x dx, right? And then I can replace this thing over here with 1/2 w squared dw. Okay? All right. Again, it's just kind of take it one step at a time and work through it really methodically. All right. So now I can pull this 1/2 outside. This becomes 1/16, right? And the integral, the integral of 1 is just x. And the integral of cosine of 4x, right, is 1/4 sine of 4x. Okay? So I've integrated this first thing. And now over here, right, I've got, I have to watch myself here. Okay, I'm going to pull the 1/2 out, right? So it becomes 1/16 times, the integral of w squared is 1/3 w cubed, right? And then plus c. So really all I have left to do now is kind of clean this up a little bit and then replace the w with sine of 2x. So let's see, we have, I'll write this as 1/16 x minus, I'll just distribute this, it becomes 1/64 sine to the 4th of x. And then I get minus 1/48 sine cubed of 2x plus c. Okay? And there you go. That's it. That's the answer. So that's what I figured was the easier way to do it. Now I did it another way first before I did this by just replacing sine squareds with the power reducing formula, and then I had to apply the power reducing formula a few times to get it to work. But I got the same answer. So I may re-record a video of the second version of this just so you could see. But just there's lots of ways to get there's lots of ways to do it. Sometimes it's just a little bit of a trick trying to find the easiest way to do it. And actually, it doesn't hurt to do it 2 ways and see if you get the same answer. The trouble is, though, that oftentimes you'll get the same answer. It'll be correct, but it'll be a different form, right? Because you get these sine, you have 2x and 4x, and you can easily replace those with different identities and get an equivalent answer. It just doesn't look the same. So yeah, you just have to be kind of really careful with these integrals. So, all right, I'll meet you for the next one.